Okay, so this is trig practice. This is the work that you had for the trig. I've got the textbook pages right here, so I'm going to go ahead and talk to you about how to do some of these. I didn't want you to have too much trouble in these. I just wanted you to get some good trig practice. So let's look at number 16. Number 16 is the first one. Now, in this assignment, you're finding all of these guys. Okay, that's trig. So you're just finding ratios. Okay, each one is a ratio, and you want to write it as a fraction. Now, let's kind of review here. We have SOHCAHTOA. So the sine of an angle equals the opposite side over the hypotenuse. The cosine of an angle is the adjacent side over the hypotenuse. And the tangent of an angle is opposite over adjacent. Okay? So those are our trig ratios. So let's look here. Let's start off with number 16. Find the sine of J. Okay. So if I want to find the sine of J, here's my angle J. Sine is the opposite of J over the hypotenuse of J. So what's opposite from J? 30. What's the hypotenuse? 34. And 30 over 34 reduces to 15 over 17. So the sine of J is 15 over 17. And you're done. Okay? Let's do the cosine of J. Remember, cosine is the adjacent side to the angle over the hypotenuse. Let me get this all in the frame here. So what's adjacent to J that's not the hypotenuse? 16. What's the hypotenuse? 34. So if I reduce this, I get 16 over 34, which is 8 over 17. And you're done. Okay? So the tangent would be the opposite over the adjacent. So for tangent of J, what's opposite of J? 30. What's adjacent? 16. So 30 over 16 is 15 over 8. And that's how you do the trig for each one. Now, it wants you to find the same things for L, correct? So let me find a different color here. Now let's look at everything in perspective from L. So the sine of L is, sine is opposite over hypotenuse. So the sine of L is 16 over 30, right? Opposite of L over the hypotenuse. So 16 over 34, 16 over 34, so that would be 8 over 17. The cosine of L is, remember, the adjacent side to L over the hypotenuse. So what's next to L that's not the hypotenuse? 30. And the hypotenuse is 34. And that reduces to 15 over 17. And then if we do the tangent of L, tangent is opposite over adjacent. So that would be, according to L, 16 is opposite, 30 is adjacent. So we have 16 over 30, which is 8 over 15. Now if you remember, I told you that when you do a right triangle and you look at the two acute angles, the sine of one angle is equal to the cosine of the other. The cosine of one angle is equal to the sine of the other. And that's because when you change angles, what's opposite to this is adjacent to this. And then when you switch, what's opposite to this is adjacent to this. So that's how you do that first group. Now let's look at one where you probably have some questions, maybe with reductions. And let's look at number 20. Okay, so let me move this out of the way. Sorry, I've got some stuff up here from my kiddos. So let's look at number 20. When we look at number 20, let's do L. Okay, I'm going to do L for you, and then I'll leave the rest of them for you. So on number 20, let's do L. So let's do the sine of L. Okay, let's look at L. Sine is opposite side, which is 2 square roots of 3, over the hypotenuse, which is 2 square roots of 15. Okay, so this is one where we actually have to rationalize the denominator. Well, first of all, what do the 2's do? They go away, right? They reduce. So I'm just left with square root of 3 over square root of 15. But I don't want the square root in the denominator. Remember we talked about that? We want to rationalize the denominator. So I'm going to multiply by square root of 15 over square root of 15. And since these are all underneath, I can multiply them together. So 3 times 15, square root of 45. over 15. Okay? Now, this one again is a little bit of fun because we'll get, what did we start again? Let's go back to the beginning first. Opposite of L is 2 square roots of 3. Hypotenuse is 2 square roots of 15. So I've got 3 square root of, over square root of 15 when I reduce the the 2. Then I multiply by 15 to get rationalized denominator. But now, square root of 45, I can take square root of 45, and I'm going to come back up here. Square root of 45, if I factor 45, I have 3 times 15. 15 is 3 times 5. So I've got a pair of 3's, right? So I can actually make that 3 square root of 5 on top because I have a pair of 3's. Remember, for every pair, 1 comes out, 5 is left underneath, over 15. And then square root, and then 3 over 15 reduces to 1/5. So square root of 5 over 5. Now that seems long, but all it is employing all the practice that we had on rationalizing the denominator. So that's the hardest part of this. I'll give you partial credit if you can at least give me this one, but you need to be able to rationalize, okay? So let's look at the next one, and I may go into a separate piece of paper for this so that you can see it. The next one is the cosine of L. Remember, cosine is adjacent over hypotenuse. Well, what's adjacent to L? 4 square root of 3, and the hypotenuse is 2 square root of 15. So my cosine, let me see if I'm in the frame here. My cosine of L is the side adjacent to L over the hypotenuse, which turned out to be what's adjacent to L? 4 square roots of 3 divided by the hypotenuse, which is 2 square roots of 15. First of all, let's reduce. Oops. Let me go ahead and put that in the frame so you can see it. So let's reduce. 4 divided by 2 is 2, so I have 2 square roots of 3 over square roots of 15. But I don't want the denominator to be like that. I want to rationalize it, so I'm going to multiply by square root of 15 over square root of 15. I get 2 square roots of 45 on top and 15 on the bottom. Now remember, square root of 45, from your previous problem, we simplified it up here, right? 45 is 3 times 3 times 5. So if you want to look at it the long way, the square root of 45 is the square root of 3 times 5 times 5. So you got a pair. For every pair, 1 comes out. Whoops. Sorry, not 3 times 5 times 5. It has been a long day. Let me write this again. It is the square root of 3 times 3 times 5. There you go, Stoughton. So there's your pair. The 3 comes out, the 5's left underneath. So on top here, I have 2 times 3 square root of 5 over 15. Okay? 2 times 3 is 6, so I have 6 square root of 5 over 15. And then I can actually reduce that. 6 over 15 reduces to 2 over 5, because 3 goes into both of those. So that is your final answer for cosine of L. These are longer. I know these are harder, but again, if you can at least get me to that point, I'll give you partial credit. But we have to rationalize the denominator and reduce. So let's do one more. Let's do the tangent of L. Okay, so I'm going to do the tangent of L. Tangent, remember, is opposite over adjacent. So if you look at L, opposite is 2 square roots of 3. And adjacent is 4 square roots of 3. So L is opposite over adjacent over 4 square roots of 3. This one is actually one of the easier ones to do, because that reduces to 1/2, right? And what do the square roots of 3 do? They go away, so it's basically just 1/2, and you're done. So that's how you handle those ugly bears problems. You have to rationalize, okay? Now you also had to do 34 and 35, so let me turn the page here. And you had 34 and 35. Okay, so let's look at some gymnastics here. Alright, so for this one, it says the springboard that Eric uses in his gymnastics class is 6-inch coils. Okay, so 6 inch is your height and forms an angle of 14.5. So here's the 14.5 angle, okay? How long is the springboard? Now this is the inverse trig, okay? I'm going to take this triangle and I'm going to draw it out for you over here. How high do we know that the coils are? 6 inches, right? And what is our angle of incline? 14.5, right? That's that angle right there, okay? So the question is, how long is the springboard? That's here. How long is it? Well, let's look at our triangle. We know this forms a right triangle. This is the height of the coils. This is our angle right here. And that is our, and that is our springboard. Well, let's call this, this is angle 14.5. What two sides do I have? I have 6, which is the opposite, right? And I'm looking for x, which is the hypotenuse. Which trig function is opposite over hypotenuse? Sine. So I'm going to set up sine. So the sine of 14.5 degrees is 6 over x. Okay? 6 over x. Now, you can solve this just like a proportion. Again, what did I do? I'm looking at a springboard. If I look at the springboard from the side, okay, if I look at this guy from the side, this is what it looks like. Not that ugly thing. If I look at this guy from the side, I have a 14.5 degree angle right there. I have 6 inches right there, and I'm looking for this. So, and it's a right triangle, so I'm looking at sine. It's just this time I'm not missing the angle or the ratio, I'm missing one of the ratios. Sine 14.5 is just like any number. You can enter that in the calculator. So I do not have my calculator with me, so I'm going to go to an online calculator. Sine of 14.5 degrees. Okay. And sine of 14.5 degrees would be 0.25. Okay? So let's move this over here. I'm gonna go ahead and draw this on this paper, okay? Here we go again. We've got our triangle. I'll make it big. We know our coils are 6 inches tall for our springboard. This is a 14.5 degree angle, and I'm looking for how long this is. How long is the spring? It's like the vault in gymnastics. How long is it? The two sides I have are the side opposite the angle, and I'm looking for the hypotenuse, so that means I'm going to use sine. Okay. So the sine of 14.5 degrees, the ratio that you get for 14.5 for opposite over hypotenuse is 6 over what? So I'm going to find sine, which is 2. If you put this in your calculator, make sure your calculator is in degree mode. Degree mode. When I plug sine of 14.5 in the calculator, I get 0.2504. Okay? That I can put that over 1, right? Okay? And that's going to equal 6 over x. So all you do from this point is you cross multiply like any other proportion. So I have 6 times 1 is 6, and 0.2504. We always go to 4 decimal places, by the way. That's just something I do to make it accurate. Times x. Now what do? Solve for x. So I divide both sides by 2.2504. And if you do 6 divided by 0.2504, you get 23.96, which is about 24. Excuse me, I'm still sick. So the answer is 24. So that's how you do those. Those are thinking questions, and I wanted you to set them up. So that's how you set those up. So that'll give you a little bit of help with your trig.